Hi everyone, my name is Steven Roselle. I'm a Senior Solution Engineer at Autodesk, and today's webinar is going to be focused on Maya at Siggraph 2012, and specifically we're going to focus primarily on the Maya 2013 extension release, which was actually announced at the show at Siggraph. And these presentations that you're going to see were actually shown on the show floor and at our main booth. For those of you that aren't familiar with the extension release, this is actually the new name for what was previously called the Service Advantage Pack. Now, the Service Advantage Pack was the intermediate subscription drop for users that were on my subscription. And this is, again, the new name for that, called Extension Release. So just wanted to clarify that. Now, in the extension release for 2013, we've added a number of nice new features. And we're going to focus primarily on these three features. DirectX 11 in Viewport 2.0, the file path editor, and scene assembly. So these are all three new either features or workflows. So first one we're going to talk about is DirectX 11 in Viewport 2.0. This is basically the ability to now boot Maya in DirectX mode. So Maya natively and historically has been OpenGL. Now it can be booted into a DirectX mode, which would then allow you in Viewport 2.0 to load custom HLSL shaders, .fx files, in order to create your own custom shaders. For instance, you can actually view your actual in-game shaders directly in the Maya viewport using this new DirectX 11 mode. So I'll show some examples of that using a number of different scenes. I wanted to give a quick plug. The image that you're seeing here and the image that you'll see in the demonstration later was created by Jesse Sandifer, and he was nice enough to contribute this, and we're using it in our demo, so I just wanted to give him a quick plug. Another thing that's been added is the file path editor. The file path editor is basically a UI for repathing missing files. So files that are external to a Maya scene, such as image files or image planes or things like references, basically things that have a file path associated with them. If those things are moved or if they're relocated, you can now use the file path editor to find them and reassign the appropriate paths. The scene assembly workflow is a very intricate workflow for managing large scenes and large environments, things like game levels and things like film sets. Basically what it allows you to do is create representations, or rather define representations of a given object so that you can easily control how and when and what you're seeing within the context of a large scene, so that you can optimize performance and get better interactivity and so on. And before we get into the demonstrations, I want to just point out a few additional features that were added in 2013 extension release. These features are a little less obvious, but important nonetheless. One is a new option for deferring the load of textures when you open a new scene. So if you now open a scene and your textures are disabled when you save that scene, then it will not load the textures. So if you have a very large scale environment, you can actually load it very quickly, and the textures will actually only load into memory upon display. So this is actually a long-standing request by many users that are working with large scenes, just the ability to speed up the opening of these large scenes. We've also made just general texture performance improvements to Viewport 2.0, as well as display improvements. For instance, the texture filtering has been completely redone in Viewport 2.0, so that now if you're looking at textures up close, you get nice sharp filtering. If you're looking at textures at a distance, objects at a distance, you get nice smooth filtering. We've also improved the floating point precision for Viewport 2.0, so when you're dealing with large scenes, when you have objects that are far away from the origin, you can prevent math errors when basically manipulating those objects because of the improved floating point precision. And then lastly, in Viewport 2.0, we also have new support for the component isolate select mode. So if you isolate select some faces, you can actually see that now in Viewport 2.0. And then from a performance standpoint, we've done a number of tweaks to some of the modeling tools. So for instance, the combine, extract, separate, and Boolean tools have been greatly improved in terms of their efficiency and performance. They haven't changed in functionality, but they've been rewritten at a lower level to make them behave more quickly or work more quickly. Finishing off the presentation today, I'm going to hand it off to my colleague Lee Frazier, who's going to give you a quick overview of a presentation that he gave at Siggraph focused on Maya 2013 and bullet physics. So let's get started with the presentations. In the recently announced Maya 2013 Service Advantage Pack, we announced support for DirectX 11 in the Maya viewport. Now, in order to actually use this, you first have to switch Maya into DirectX 11 mode. So if we simply go under Windows Settings into the Preference UI, and then under Preferences, if we go under Display, we now have a Render Engine option. Here we can switch between OpenGL and DirectX. Maya by default will boot in OpenGL. If you want to view DirectX 11 or HLSL shaders, you switch over into DirectX rendering engine, you save this, and then you reboot Maya. A couple of other things to point out. In order to actually use this, you have to go under the plugin manager, and you have to make sure that the DX11 is shader is loaded. So we have a DirectX or DX11 shader plugin .mll. Make sure that's loaded, and then when we go over into the hypershade, what you'll notice in the hypershade is that I now have a node. If I pull into this, I now have a node called DirectX 11. When I create this, I get a raw DirectX 11 shader. And from this, I can go into the attribute editor, and I can actually load in any custom shader that I might want to use. If you go to the Maya 2013.5 presets under HLSL 11 examples, you'll find that we have a number of examples that you can use for prototyping purposes or testing purposes. These are all fairly standard .fx files, and when loaded, for instance if I choose the lambskin, that will automatically configure the parameters accordingly. So based on the contents of the .fx file, it will actually go in and it will build the parameter list on the shader node. And that will get rebuilt with any new FX file that's brought in. For instance, if I bring in my plastic Fong shadow or my plastic FX file, you'll notice that it will reconfigure these parameters. It will also automatically bind lights. If you have lights in your scene, it will take the first 3 lights in this case, and it will bind those to the appropriate light links on the shader itself. So it will use Maya native lights. So one thing that we provided is something called the Uber shader, which loads by default. I actually unloaded it, but if I load this again, what you'll notice is that I now get a single shader that has a number of parameters built into it. So again, the lighting that I mentioned before, ambient and effusive parameters, diffuse parameters, opacity, specular, normal, reflection, and then tessellation and displacement, as well as translucency. So these are basically multi-purpose effects, and this is a single shader that basically allows you to create a whole wide array of different types of rendering and lighting effects. So let me load up a pre-built example to show off some of these effects. So here you'll see a character. This is called the Minion character, and he's actually the enemy of the Spaceman character that you may have seen in some of the other demonstrations. What you'll see here is I have a single shader that is basically creating all of the various effects that you see here. So you'll see the skin shader effect on the character on the inside of the mask. You'll see the reflective effect on the face mask itself. You'll also see a number of layers here, including things like bump and normal maps, as well as different specular maps. If we go to the top, you'll see a glowing effect here, as well as a glowing effect around the back here. And again, these are all created using the single Uber shader that has just been configured to provide different looks. So in order to access the shader, I'm just going to simply select a piece of geometry, and that will load its associated shader, and then I'll reselect that in the attribute editor. Now again, you'll notice this is just the standard Maya Uber shader, and if I scroll down, I can show a few of the different effects. So we'll pass over lighting for now, and the first thing we'll talk about, of course, is diffuse, which can be toggled on and off very easily. And then in addition to that, I'm going to scroll down and we'll talk a bit about normal and bump. So we can apply normal and or bump maps here. Right now I have a normal map, and then I've got a simple offset value that allows me to control the offset of the height. I can also give this a negative value if I want to invert that. So let's bump that back up a bit, and we'll go around and look at some of the other parameters. We also have a specular map option with a specular color and specular power associated with that. Very straightforward. We have opacity, which we'll talk about in a second with the face mask, but for now we'll go in and talk about one of the more unique parameters, and that is the ambient emissive. The ambient emissive is actually the ability to create kind of an ambient lighting effect based on either the sky, which you'll see is shining from above, essentially creating an ambient effect from above, and then likewise I have a lower lighting value, which is basically working as the ground, and that was actually set to kind of an orangish color. We can also mask out different pieces of our texture and create glowing effects with ambient emissive maps. So what you'll see here is I have an ambient emissive map on the back of the blaster, or the booster rather, as well as the blaster of the gun. These are actually controlled by a texture. Now it's a little hard to see here with the swatch size, but this swatch is actually masking out those areas. And if I were to actually go in and disable this, let's say for instance I select and then just simply delete the node, you'll notice it actually removes that effect altogether. So now I'm not getting any of the ambient emissive effect. If I undo that, you can see I get the ambient emissive effect back. So again, it's kind of a multi-faceted attribute that can be used in different ways to create different kinds of effects. So it is kind of a Swiss Army knife of shaders for the viewport. What you can also see here is another example of the shader with the face mask. Now if I select this face mask and then go in and actually find its associated material, what you'll notice is that this is also the Maya Uber shader, but it's giving me a very different look. In this case, it's primarily using transparency, specularity, and reflection. If I go in and turn the reflection on and off, you can see it's using an environmental reflection map, and then I've got a variety of controls that control the intensity of that reflection as well as the blur of that reflection if I want to make it crisp or very dull. And then some interesting Fresnel effects. The Fresnel effects are basically controlling the kind of fall off between fully opaque, fully transparent, and non-transparent. So you can see here where the reflection is on the border and the fully transparent is on the interior. I can actually switch these and I'll get the opposite reflect, where the reflection is actually head-on, as well as the specularity. So I'm going to just kind of dial that down a little bit, and then of course I also have control over things like the specularity, which I can control either with maps or just with a solid color, and I have a power associated with that. So that's the kind of combination of, again, specularity, reflection, and transparency. Now I'm going to go in and actually grab the character on the inside of this. So here you can see I've got the head selected. The wireframe is being masked out by the DX shader. And I'll go in here and you'll notice once again this is also using the Uber shader, although it's giving me a very different effect. In this case it's using a mode, or rather an effect called translucency, to give me a subsurface scattering type effect. If I turn translucency off, what you'll notice is it actually gives me kind of a backfill that seems to kind of permeate across the surface and through the surface to create the skin effect. So with translucency I have not only the toggle, but I also have various controls over the amount of distortion, the fall off, and so on. I also have a gradient color that I can go in and I can set to change the kind of relationship between non-translucent, or the inner translucency, and the outer translucency. So right now I have that set to yellow. I could go in here and I could set this to something like a blue, and you can see the effect that that gives you there. Much more kind of alien, kind of foreign looking. But I can of course switch this back into more of a natural skin tone and then define the power and the fall off relative to that. And again, giving me kind of a fake subsurface scattering effect. So this example shows a number of effects that can be achieved. One, by using standard or native Maya lights in conjunction with DirectX 11 shader. So if I go in here and actually turn on my lights, you can see I'm just using standard Maya spotlights, and as I begin to move these spotlights, you can see how that actually updates in the scene, and again in conjunction with the shader. So I can add color, or I can change the direction of the light, and that will of course directly affect the look of the shader. So let's go in and turn off the lights, and we'll talk about one last kind of important element to this, and that is the ability to do real-time displacement directly in the viewport based on the shader using the Uber shader using displacement maps and vector displacement maps. So what we'll see here is if I go in and I select this object, you'll notice that when I select this, the wireframe displays, but it's not actually in alignment with the mesh that is being rendered. So if I actually go into standard shaded mode, then I'll just see a standard Maya mesh with a standard kind of Lambert looking shader on it. If I were to go in and turn on my full texturing, then you'll see the difference between my base mesh and my tessellated deformed mesh. So let's actually go into the attribute editor here and just grab the material or the shader for this. And you'll also notice that it automatically hooked up into the lights. So when I imported the Uber shader, it found the lights in my scene and hooked those up. I could also go in and hook these up manually if I need to. One thing to point out here is if I go in and take a look at the actual displacement map, which is down towards the bottom, I can turn that on and off. And by simply turning that off, you can see I get the original look of the shape without the effect of the displacement. Now if I were to go in and actually turn off the wireframe here, I can do a number of things. In addition to that, I can go in and I can tweak the height of the displacement. So now what you're seeing is an interactive displacement, basically going from no displacement to full displacement. Then I have the ability to go in and increase or decrease the tessellation range. This is actually increasing and decreasing the amount of tessellation that's happening. In other words, the number of polygons that are being generated on the fly. If I want to actually see the resolution of the geometry in its displaced form, I can actually come up here and I can turn on a simple parameter. So I have tessellation on and I have tessellation off, which will allow me to toggle between the two view modes, but I also have a wireframe mode. This allows me to actually see the wireframe post tessellation. So now if I were to go back to that previous attribute, I'll scroll down here and actually begin to change my tessellation range. You can see that as I change this, it increases and decreases the wireframe tessellation, allowing me to see the actual full representation in terms of number of polys in the final displaced mesh. So let's just switch this back over into standard tessellation view and pull back and get a closer look at this. Now this is actually showing not only a displacement map, but an actual vector displacement map. So it allows you to see these kind of concave, kind of cavity areas. So let's take the head here, for example. If I were to go in here and grab the head and actually swipe over this and make sure I get the right material here. And let's select the material. Just to show you the example here, if I were to go down a little bit and turn on under my tessellation settings, the actual vector displacement, what you can see is it's actually creating some curvature, some underlying curvature on the surface. So if I were to go in and start to tweak this height, you can see it's actually not only displacing outward, but it's actually displacing in kind of an angle. So it's actually not only displacing along the normal, but it's actually distorting that normal or warping that normal essentially as it displaces it. So this is a map, the vector displacement, tangent vector displacement rather, is a map that could be created from a high resolution mesh in Mudbox and then just brought right into Maya and then viewed in real time in the Maya viewport. So one last thing to point out is that this all works in conjunction with Viewport 2.0. You'll notice up here in my viewport it says Viewport 2.0 DirectX 11. So you do have to be in Viewport 2.0 to take advantage of some of these rendering effects, but you also get the addition, and in addition to the effects of the shader itself, you get the effects of the viewport. So for instance, one example is if I were to go in and select the camera and go into the camera attribute editor, what you can see here is I'm seeing the shader. But if I turn on depth of field, I'm also seeing the effect of that depth of field. Now it's not quite as obvious here, but if I start to tweak my focal distance here, you can see that as I pull that focal distance out, that blurs the point of view of my camera. As I pull it in, it starts to sharpen, and then based on the distance of the camera, it's actually sharpening or blurring the effect of that shader relative to the position of the camera. So let's pull that up a little bit. Let's bring my focal distance back up to a higher value and pull back. And let's talk about some of the other viewport effects that we can combine with this. I'm going to bring up my hardware rendering settings here for Viewport 2.0 and talk about some of the other things that we can add. For instance, I can go in and I can add a simple gamma correction. Now if I do gamma correction on the viewport, you can see I can actually dial up and dial down the gamma correct. If I go in and I add something like anti-aliasing, I can basically sample, do multi-sampling anti-aliasing, and I can increase or decrease the kind of smoothness of the surrounding edges. We also have the ability to do screen-based ambient occlusion. You can see the difference with and without the screen-based ambient occlusion. Then I've got sliders that allow me to dial that up and dial that down. So again, this is using Viewport 2.0 with all of the nice rendering bells and whistles, the viewport effects that are tied in with this, in conjunction with all of the nice rendering effects that are tied in with the Uber shader or DirectX 11 shader. In the Maya 2013 Service Advantage Pack, we added a simple utility for correcting paths for external scenes or external files from Maya. So for instance, if you're missing a bunch of textures or if you're missing some file references because someone has moved them or because you've moved a project around and they're no longer local to your project, now you can actually repath those using something called the file path editor. So what you'll see here is I've got a couple of things going on. One is I've got a reference in my outliner. If I right click on this reference and try to load that reference, what you'll notice is that it doesn't do anything. It actually gives me an error telling me that it cannot find the associated reference. Now in the past I'd have to manually go in and correct that, reference by reference, one at a time. Now I can go into the General Editor's File Path Editor, and here I get a list of all of the possible file paths that are in this Maya scene. So pointing to things like textures, audio files, image planes, and in this case, references. So anytime I see an X, that means there's a missing path or a missing object. And if I expand that, you can see it actually, in this case, is a reference. So if I wanted to correct this reference, I can basically just select the reference directly, and I can go into my repath option, and here I can specify a new search location. So you'll notice I have a scenes file and I have a new anim scenes file, which is where I'm keeping all of my referenced animation files. So I'm just going to point to that new anim scene file, apply that, and then if I preview, it'll show me the previous path with the new path based on the folder that I've chosen. So now when I say continue, it will go in, find the associated file for that reference, and load all of its contents. Now when I come back into the scene, you can see that it did indeed load my object into my scene. This is actually a character rig that can then be positioned relative to the rest of my scene. You'll also notice that if I pull back, I'm missing a bunch of textures. These also are external to a Maya scene and have paths associated with them. So textures generally will be missing in batches or bunches. So what I can do is I can go in and expand the list of all of the possible textures that I may be missing. And you can see that I've got two path locations. I've got a source images folder, in which case I've been able to find all the textures, and I've got a level textures folder within that that is missing a bunch of textures for what looks to be all of the buildings. So rather than going in and replacing these one by one, I can go into the select options and I can select either all by type, in which case it would select all of the textures, or I can actually go in and just select anything that has not been resolved by default, and that will go in and select all of the missing elements basically that I need to correct. Then I can go into my repath, and instead of going to this specific folder that I want to search from, I can actually set a higher level folder. So for instance, I can go up to a higher level. For instance, I can go to my Maya 2013 folder, or I can go into a subfolder from within that. Actually, I'm in the wrong folder. Let's go into my Spaceman folder, which is basically the highest level of my project. Now I can set that, and I can turn on the include subdirectories. And what that will do is it will go into all of the underlying subdirectories and find all the associated paths and correct them accordingly. Now when I come back into my Maya scene, you'll see that all the missing textures are now reloaded into the Maya scene. So again, anything in a Maya scene that references a file that is external to the Maya scene requires a file path, and those file paths, when they're incorrect, can be easily remapped. In the Maya 2013 extension release, we've introduced a new workflow called Scene Assembly, which is basically a workflow for managing and assembling large levels like game environments and film sets. So here what you see is a section of a game environment, and you can see I've got a bunch of stuff that's been loaded into this environment. You'll notice also that it's not textured right now because each one of these currently is a proxy representation or a cached representation of the final object. So what I can do once this scene is loaded is I can grab any one of these objects, and you'll notice that it displays in this kind of dotted line wireframe. That indicates that it is a cache. It's also shaded in this kind of gray, which could be a customized color if I wanted it to be. So if I right click on this, you can see that I get a scene assembly menu, and from that I get a list of options that allow me to switch, for instance, between bounding box mode and detailed mode, and even a simpler mode, which is a locator mode. So this is basically a trigger for different representations of the same object. This allows me to basically go in and offload things that I don't need to see and load things that I do need to see, and see kind of streamlined representations in cache format or bounding box format for the kind of intermediate levels. So if I pull back, for instance, I can actually go in and I can take all of the stuff on this side of the level, and I can just simply switch that over into a locator mode, and now you'll see that it just renders all of that or displays all of that in its simplest form, which is location or locator. So now let's talk about how I would actually create these scene assemblies. In order to work with scene assemblies, we have the ability to create two new node types. If I go to the Create menu and pull down into Scene Assembly, I have the ability to create assembly definition nodes and assembly reference nodes. I'll talk about assembly references in a minute, but first we're going to create an assembly definition node. You can, by the way, also create these directly in the outliner just by right-clicking and essentially doing the same thing. It's just a shorter way of doing it. So now I've created an assembly definition node. What this is basically it encompasses everything, all the information, and all the various representations of a certain asset that you want to bring into your scene. So in this example, what we're going to do is we're going to point this. This is basically kind of an encapsulation node that will point to other files. So I'm going to start by pointing this to another scene, which is going to contain the detailed textured version of whatever object I'm working with, which is the obelisk here. Now what I want to do is also point this to a cached version. So I can create this in advance, or I can go in on the fly here, and I can just do a GPU cache export and save this out as an obelisk.abc, which is a cache format, ABC for Alembic. So I've created the Alembic cache file, but I haven't actually linked to it. So now what I want to do is create a cache representation and point to that. Now I have my master scene, which is my Maya scene file, and I have my cache version of that object, which is a fast draw GPU mesh. So let's create a third representation. I'll switch over to my main scene file, and this time I'm going to go to modify and use the new bounding box conversion tool to create a simple bounding box representation of this object. Now I can do it in a couple of ways. I can either create a single bounding box representing the volume of my object, or if I want to get more detail out of this, I can switch into a per shape mode, and I'll combine these into a single object. And now I'll basically go in and I'll get a single bounding box for each piece of my object, which gives me a better representation of the shape. Now I can actually take this and export this as its own cache file, and we'll just add a BB onto that, obelisk.bb or _BB. And then I'll go back into my assembly definition node. Now I've created the bounding box. I'm just going to undo that because all I did was create it. I haven't actually associated it with the assembly definition now. So now I'm going to go back a couple of steps and I'll add a second cache link to the bounding box. So now I have my Maya scene, I have my cache file, and I have my bounding box. I also have a fourth representation which gets created by default, and that is my locator. This is just simply a point in space. And what this basically does is gives me a simple point in space with a label that can be associated with it. So I'll go in and I'll label this something descriptive like obelisk, and now you'll see that actually shows up in my viewport as a simple label on a locator. So the last thing I want to do in this case is go in and give these some descriptive names using labels. So locator is pretty descriptive. I'm actually going to go into the scene file and I'm going to call this something like detail or scene. Then I'm going to go into the cache. I'm going to call this simply cache. And then for the bounding box, I'll call this bbox. And again, I'm just changing the labels on these objects. So now, whenever I select the node, either in the viewport or in the outliner, I can right-click on that node, and I get a list of all the representations: locator, detail, cache, bounding box. So now I can switch over into detail mode, and I get the fully editable, fully detailed version, or I can right-click and switch over into bounding box mode, and likewise I get the bounding box representation. So this gives me a quick way of managing all of the different representations. And again, as I load one versus the other, it will unload all of the other representations, giving me kind of an efficient way of switching between the views. So now what I would do is save this out as its own file, and then I would reference it into a larger scene. So before we get into the larger scene, we're going to talk about another way of actually using scene assemblies, and that is for creating variants of a given object. So here I have a building, and if I wanted to actually see the detail, you can see it's in cache format right now, so I'm pointing to an external cache. If I wanted to bring a character in here and have him go up to that door, if I need to see the detail on the door, I can simply grab this object, right-click, and switch over to detail, and now I get the fully detailed representation of that building or that section of the building. But you can do this in a hierarchical manner. So instead of loading the detailed version of the individual components, I can go up one level, and I'm using a separate assembly definition to basically allow me to trigger different variants or different variations of this building. So I can switch between, for instance, a short building, and I can switch to a tall building, and I'll get, again, different representations. And then if I wanted to see the actual details, I can grab the lower level representations, and I can switch over into detail mode in order to load the fully editable, fully detailed version of the tall building. So now we're back in the master scene, and what you can see is I've got, again, a bunch of cache files loaded. So if I wanted to go in and see the fully detailed version of this object here, again, I just simply right-click, switch over into detail mode, and now I've flushed out the cache and brought in the fully editable mesh. So if I wanted to basically bring in a simple asset or a specific asset, the manual way of doing this would be to go to the outliner or to go to the create menu and to simply create an assembly reference. Now an assembly reference is a pointer to an assembly definition, which in turn is a pointer to all of the various representations. So I'll create an assembly reference, and then I'll simply point this to the assembly definition file that I created earlier. So I would have saved out the obelisk definition with an _AD or something descriptive to let me know that that is an assembly definition. Now each file, by the way, can only contain one assembly definition node, so that's important to point out. So what I did is I loaded or referenced that assembly definition into my scene. Now I can go in and I can position this and orient this accordingly using the cache representation, which again is a fast draw version of this object. Again, if I want to see the detailed version, I right-click, switch over into detail, and now I can see the detailed version. And you can also see that that detailed version has inherited the edits that I applied to that original cache. So it shares edits across the representation. So if I wanted to bring in some other objects, the first thing I'd probably do is basically figure out what I don't really need to work with right now. So let's say I don't really need to work with anything on this side of my environment. So I can basically flush this out into locator mode, and now you'll see it'll simply show me the locators of those objects. Now I can come in here and say, well, maybe these particular objects here I really want to see in bounding box mode because I need to see where they are, but I don't really care exactly what they look like. And the same thing with these particular objects here. Maybe I need to switch these into a bounding box mode so that I can see generally where they are, but not detail. And it looks like I accidentally turned this into a locator. Let's just switch this once again back into my detailed view. And now I can basically focus in on just the area of the environment that I care about, and I've flushed out everything else. This gives me higher performance and better interactivity while I'm laying out my level. So now if I wanted to bring in some other assets, I could of course go to the outliner, right-click, and create a reference, but that's a very manual process. So the idea with this is that you can write your own front end that takes advantage of this system or this workflow. So what I've done is I've created a tool called Layout Tools, and as part of Layout Tools I have an import mechanism that allows us to import objects into our scene. Now when I set it to import, it will basically look at a repository of files, and it will create a pointer to every Maya file that it sees. So what I can also do is I've modified this to specify reference nodes, and if I set this, or assembly nodes, if I set this to assembly, what that will do is it will look for any file that has a suffix of _AD, and it will build an icon and allow me to basically create an assembly reference to that definition file. So for instance, if I'm looking at this here and I decide I need to fill in this white space or this empty space here, I can go in and I can import in a building or reference in a building, then I can kind of drag and drop that into place, position that accordingly, and then if I decide at a different point, well, I really need the tall version of that building, I'll just simply right click. I'll switch over into to the assembly definition version, which is the tall version of this building. Then I can go in and I can add things like scale. I can even switch the building type if I want a different type. So from here, what I can do is I can start to bring in other assets. So I've got simple shelf buttons that link to structures, which basically give me all the larger objects that I might want to bring into my scene. So I'll bring in a structure here and kind of drop that into place right about there. I'll bring in this structure here and I'll kind of drop that into place right about there. And I'll kind of slowly but surely start to populate this environment with various types of objects or various types of structures and buildings. So I might want to drag that one back there, add a little bit of scale to this. Whoops, if I can actually get the right manipulator. And then maybe pull that over, and I need to make that a little bit taller so I can actually see it. So I'll switch over into the tall version of that building, and you get the basic idea. So I've also got props that I can bring in, and the props are actually smaller components or more modular pieces like ladders and pipes and things like that that I might want to bring into my scene. So I'll kind of frame in here a little bit, and let's say I kind of want to focus on this building. I'll start to, or this little structure here. I'll start to frame in on that, and I'll begin to bring in some objects. So let's bring in some boxes here, and maybe I'll bring in a crate over here, and I'll bring in this canister here, and I might want to grab this other type of canister here, and again, just start to kind of populate my environment with these various objects. Now, one thing to point out is that each one of these is a cache right now. The thing about caches is that they are not editable objects. So if I right click on this, you'll notice I do not have access to my vertices and or my faces. So I can't actually edit these, but they are snappable, so they can be used as reference meshes. So if I bring in another canister, I can drop that into place, and I can snap that canister onto the various vertices of this building, and then I can use that as a reference point for dragging around that canister and positioning it on the building. So now if I wanted to pull back here a little bit, and I wanted to see all of this in kind of a more detailed mode, I can basically drag over all of this, everything except for my two that are already in detailed mode. I'll right click and I'll switch over into detail mode, and that will basically swap out all of the caches, unload those from memory, and load in all of the fully editable versions of these objects. Now I can go in and position my camera accordingly and get a much more kind of realistic view, clear view of how my scene or how my set is going to look from this particular point of view. Another potential way to use assembly references and assembly definitions is through a dynamic LOD loading system. So here we've just written a simple Python script that basically will load the different LODs based on the distance from the camera. So when a certain threshold is reached, it will switch, for instance, from the locator, which is viewed at a distance. If I pull in a little bit, as I begin to pull in, you'll notice that the bounding box will get swapped. And as I pull in a little closer, you'll notice then the cache representation will get swapped. And then once I get in within a certain threshold, it will cache out, or rather flush out the cache and then bring in the full detailed resolution. Again, if I start to pull out, you'll notice it switches to the cache, and then the farther I get away, it switches to the bounding box, and then ultimately it will switch to the simple locator. So again, this is just a kind of a simple example of ways that scene assemblies and scene definitions could potentially be used in the context of managing environments. So for the last piece of the presentation, I'm going to hand it over to my colleague Lee Fraser, who's going to spend a few minutes talking about Maya 2013 with bullet physics, and give you kind of an overview of the demonstrations that he showed there on the show floor at Siggraph. So here's Lee.
One of the things that we highlighted at Siggraph 2012 this year was the inclusion of Bullet, the Dynamics engine that is owned by AMD. And what you'll notice is really quickly, if I go to the plugin manager, we have Bullet as a plugin that we have the ability to load. And it loads a couple things. It loads a shelf as well as a menu item that you'll see in the hotbox. If I had a little more screen real estate, you'd also see it up on this top row. Now, Bullet as a dynamics engine is very robust. It handles a large number of objects, but it also handles soft bodies as well as ragdoll physics. So the way it works is really simple. All we have to do in this case is we'll just create a couple of objects here. I'm just going to duplicate this guy and we'll rotate it around, and I'm going to use Shift D and start creating just a spiral all the way up, and we'll create about 100 of these objects, nothing too complex, but then we'll duplicate that and we'll create essentially a lot of objects colliding at once, and that's not too bad. Let's use that as an example. And we'll duplicate these guys one more time, and we'll kind of shift those over just a little bit, and that'll work for me. So we'll take the two spirals that we have, and we'll just create active rigid bodies out of all of them. So I'm selecting all of them and just going to, I'll reset the settings, because what this does is it uses the collider shape type as a box by default. Now in this case we could always go to hull and actually use the geometry, but in this case since we just need a simple stand-in, we'll apply that, and all of the objects will then become dynamic. So the last thing we need to do is give them something to collide against, of course, so we can just create a passive rigid body. In this case, the body type, instead of kinematic, we'll use static. If it were kinematic, it would sit still until something physically ran into it. In this case, we don't want it to move, so we'll create a plane in the scene, and this will just act as a virtual plane. If I scale this up, you can see it, and all of our objects will collide against that when they encounter it. So one of the things you'll notice is our scene scale is pretty small, so we'll just increase the amount of gravity influence. We'll basically change the gravity amount in the scene. And as soon as we do that and hit play, you can see that we get all of those objects, we get a nice playback rate, and we get good collisions on all of those objects. So that's a really simple example of how Bullet works. Here's an example of the same spiral shape with a plane that's been converted to a Bullet soft body. You can see that we've got a constraint here that's holding or pinning part of this object in place, and you can see our objects just sort of collide and bounce off and get a little bit of reaction to the soft body, but we can change that really easily by just going in and simply converting or increasing our mass, and we'll get a different result from the soft body. And you can see those sort of start to pull, and we get a much different result from the soft body. We can increase the tessellation of this. We can use our smooth mesh preview. There's lots of different ways of viewing this dynamic simulation. One thing that's also interesting is if we decide to scale these objects up, we have individual control over those. Now in this case we're going to create some interpenetration, but Bullet doesn't really care. It's going to do its best job that it can to just sort of blow those objects apart, and you can see again we get a pretty interesting dynamic simulation. It doesn't fail, it just sort of continues to solve, and we get the result that you see there with the combination of soft bodies and rigid bodies. Here's another simple Bullet scene that we're going to use to show the editable nature of the animation surrounding some of the dynamics events. So in this case we've got our spaceship, and if we hit play you can see that we get some nice playback. We've got, I don't know, I think several hundred crates here, and as the ship flies into them we get the obvious collision. And the nice thing about Bullet is just due to the speed we can iterate and try different things. So what I'm going to do in this case is just go to my anim car, and let's double check the number of those crates. So we've got 500 crates here, so a significant number larger than the spiral examples. What I'm going to do is just create a simple editable motion trail and change the animation on the fly. So I'm just going to change the collision point at which the ship hits the crates, and we'll kind of have a little steeper angle of descent. We'll hit play, and immediately we get a different result. You can see that the ship flies in and hits it at a different angle, and my dynamics scene updates accordingly. So this is a really great way of trying out your dynamics in your scene and getting some different actions and results from the dynamics engine. In this last example, we're going to take a look at how we can use Bullet to allow our characters to interact with our dynamic objects in our scene. So in this case, you can see our character gets hit by our plasma ray and falls back into the crates, and we want the crates to react to the animation of the character. So what we'll do is first off, just as we did in the first example, we're going to create active rigid bodies out of these objects. And I'm going to use hull as the object type, and we'll apply that and close our option box. And from here, all we need to do is hit play, and you can see that they react appropriately. I've already got a virtual plane in the scene, just like we created in the first example, so the creates will hold their ground when they start to fall based on the gravity. And now all I need to do is take my skeleton and go to my bullet menu, and I'm going to create colliders for each one of the joints in my skeleton. So we'll just go in and do that. There's some size options in the option box that you can play around with, but in this case what we wind up with is a set of capsules. Now in this case I'm just going to turn everything off, or at least my polygons off, and you can see that we get these capsules, and each one of them essentially has their own transform. We can scale these up and down, or we can delete them. We can go in and create things, basically change their location. Let's move this guy up a little bit, so we'll have his head be a little bit larger and a little more round, similar to his real head. And then any of these capsules on his torso, we can go in and change the size of those really quickly just by using our transform manipulators. They can overlap. It doesn't really matter. If we want a really large one, we can do that really easily as well. So that is how we create our overall colliders. Once we're done, we'll just bring back our polygons and we're set to go. We can hit play, and now our character will react appropriately to the rest of the objects in the scene, and away we go. Of course, we can change that. Since this is space, the boxes sort of drift away the way you would expect to in space. But of course, if we wanted to change that, all we have to do is grab our solver and change once again our gravity to be something a little heavier than what we have currently. And when we hit play, you can see we get a much different result. So that is how we can use bullet physics to get some really interesting results in terms of dynamics in our Maya scenes.
Thanks, Lee, and thanks for everyone for attending. If you are interested in the kinds of presentations that Lee and I showed today, we both have blogs on the area that you can check out. Lee's is called Swedish, where he talks about a variety of the tools that are included in many of the Autodesk media and entertainment suites, including Maya, Mudbox, Motion Builder, and others as well. And his blog is at area.autodesk.com/blogs/Lee. I have a blog as well, which is called Maya, and I primarily focus on Maya, but I do touch on Mudbox and Motion Builder as well, and a few other odds and ends. But my blog can be found at area.autodesk.com/blogs/Steven R. But otherwise, that wraps up the presentation. Again, thanks everyone for attending, and we'll see you next time. Bye.